Okay, for this problem, we've got John passing through 6 sets of traffic lights on the way to work. If he has to stop more than 4 sets of lights, then he'd be late for work. So you could write, I'll just put it here, just some information just to get us started, that the probability that x is greater than 4 here is equals late. Okay. Traffic lights operate independently, so we've got independent distribution here, and the probability is 0.4, so P equals 0.4. Find the probability John will be late for work. So when we're looking at this, we can tell it's not normal distribution because there's nothing about a mean or a standard deviation. We know it's none of the continuous distributions because it's not continuous. It looks very much like a discrete distribution because we've got 6 sets of traffic lights, so it's a discrete number, and then 4 sets of lights here. So I'm thinking it's either binomial or Poisson. We don't have a rate here, which you'd normally get with a Poisson. With a binomial, you've got to have 2 options, and we can see here the options would be either stop or go. Or stop or not stop, basically. So this is very obviously a binomial distribution, okay, in terms of working it out. So with the binomial distribution, we have our p-value. Our x value is equal to 4 because he needs to find out no more than 4, and our number of trials is equal to 6 because again we've got 6 sets of traffic lights. So you're going to go onto your graphics calculator and you're going to bring up your binomial distribution, and once you get through to the binomial CD screen, you'll get through and you'll enter your data like this, and when you press execute, you'll find that the probability that x is less than or equal to 4, in this case here, is equal to 0.95904. Now remembering that that's not actually our answer there, we're only partway there, because if he has to stop at more than 4 sets of lights, he'll be late for work. The binomial distribution works from 0, so for example 0, 1, 2, 3, 4, 5, 6. What the question's actually asking you is more than 4, and so we're looking at 5 and 6, but of course the calculator works out this. So once we've done this, we now have to subtract, so the probability of x being greater than or equal to 5, which is what we want, or probably greater than 4, is equal to 1 minus 0.95904, which of course makes it 0.04096, or if you're just doing it to 2 decimal places or 3 decimal places, 0.041. And that's how you work out that question.